Okay, so now we're in the section where we're going to talk about TDD, test-driven development. This is definitely a concept that you're going to have to take time and really work with it, because this is one of those concepts that we're saying to write the test before you write the functions. So that means you have to have a good understanding of the type of functions that you are creating. Now, what's the benefits of writing a test before you write the function? It's because you're thinking it all the way through. You're understanding the different positive and negative use cases. And then you write the function to fit whatever the test is. But as a new developer, you're going to be writing the function first, then the test. It's a process. It's going to take some time to really master this particular concept. So, if you're new to the channel and you would like to follow along in this curriculum, the link is in the description. It is free. So, let's get into it. Test-driven development. Now that we know more about unit tests, we are going to learn a new way of using them. So far, we have written tests to verify functionality of existing code. Next, we are going to use tests to verify functionality of code that does not already exist. This may sound odd, but this process has many benefits, as we will learn. As the name sounds, test-driven development, TDD, is a software development process where the unit tests are written first. However, that doesn't tell the entire story. Writing tests first and intentionally thinking more about the code design leads to better code. The name comes from the idea of the test-driven the development process. Before we can start using TDD, we need a list of discrete features that can be turned into unit tests. This will help keep our tests focused on specific functionality, which should lead to code that is easy to read. Along the way, we will build confidence as we add features. TDD is a process that some organizations choose to use. Using the TDD process is not required when using unit tests. The test code cycle. With TDD, you start with a unit test first. Each test must clearly describe the behavior it is testing. Example test case for a data parsing project. Taking a string of numbers delimited by a character and return an array. Because the test is for a feature that does not exist yet, we need to think about how the feature will be implemented. This is the time to ask questions like, should we add a new parameter? What about an entirely new function? What will the function return? How could we implement our test case? Remember, we aren't writing the code yet, only thinking about the design. The test case will evaluate the function's name, parseData. The parseData function will contain a data parameter that gets assigned a string of data, contain a delimiter parameter that will be used to split the string into an array, return an array. parseData will be defined in a module. Next, write the unit test as if the parameter of functions you imagine already exist. This may seem a bit odd, but considering how the new code will be used, help find bugs and flaws earlier. We also have to use test utilities such as expect.toBe to clearly demonstrate that the process new code function properly. To clearly demonstrate that the proposed new code functions properly. Example. Next, type out the ideal into an actual test. In this example, A test references a module and a function that have not been created yet. The code allows the plan we came up with earlier. Very importantly, there is an expect dot to be true. That verifies an array is returned. So here we go. Here's the syntax of it, and here's the test. Here's the main test, and here's the use case right here. So pay attention to what it's doing, and noticing that it's doing an anonymous function or an arrow function. Now run the test. The test should fail or not compile at all. Because you have reference code that does not exist yet, finally write code to pass the new test. In the earlier chapter, this is where you started, but with TDD, writing new code is the last step. To make the new test pass, a file must be created that exports a parse data function with logic that satisfies the expected test. So here's the actual function. Coding this way builds confidence, and that's what we're here to do, is to build your confidence in your work. No matter how large your code base may get, you know that each part has a test to validate its functionality. Now that we have one passing test for our data parse project, we could confidently move on to writing tests and code for the remaining features. The red-green refactor. While adding new features and making our code work is the main goal, we also want to write readable, efficient code that makes us proud. The red-green refactor mantra describes the process of writing tests, seeing them pass, and then making the code better. As the name suggests, the cycle consists of 3 steps. Red refers to test results that fail, while green represents tests that pass. The color refers to test results which are often styled with red or failing tests and green for passing tests. Red writes a failing test. Green makes it pass by implementing the code. Refactor makes the code better. Refactoring code means to keep the same overall feature, but change how that feature is implemented. Since we have a test to verify our code, we can change the code with confidence, knowing that any error will be immediately identified by the test. Here are a few examples of refactoring. 1. Using different data structures. 2. Reducing the number of times needed to loop through an array. All right, this is something that we're going to talk about. We're just introducing to it. We're planting a seed with this, because this comes down to the big old notation, where we're using data structures, and how complex the code is, the worst case complexity. But that's beyond this course, but we're just trying to plant a seed here. And this is talking about how many times we loop through an array. So you know what our for loops, we have I, and then we have J, those are nested for loops. Well, that has a very big complexity. Or N, that means it uses up a lot of resources in order to make that happen. But again, this is just planting a seed. Moving duplicate logic into a function so it can be reused. And it says the refactor is also done in the TDD process. Decide how to improve the implementation of the feature. 2. Change the unit test to use this new idea. 3. Run the code to see the test fail. 4. Refactor the code to implement the new idea. And 5. Finally see the test pass with the refactor design. Okay, so we made it to the end of this particular section. You may not think it's a lot to doing unit tests when you first open up this chapter, but It's a concept that you definitely gonna have to practice so that you can get better at it. You gotta write more functions, and you gotta test those functions. And the more you test your functions, the better you're gonna understand how to write those functions. Okay, so that's the end of this section. Remember, the more you do, the more you improve. Okay, see you in the next section.